Hi guys, my name is Ryan. If you're watching this video, it seems like you're interested in what SimStandard has to offer for you. So let's take a look at that and see what it entitles. In a nutshell, it's pretty much static loads on parts and assemblies. So let's see what that looks like inside of SOLIDWORKS for us. What I have here for you is a plate that our engineering team has designed for us. And what we want to do is pull on it in the opposite directions and see what happens to it. It's better to find that out now in the program than actually after production. So let me show you how quick and easy it is to set this up. All we have to do within SOLIDWORKS is create a brand new study. And the setup is pretty simple and easy. We apply a material to our part itself so that we know what sort of properties we're working with. We're going to create a fixture on one side to hold this thing in position so that we can actually tug on this. Now we need that tugging force, so I'm going to add a quick force to the opposite side of this plate, and we'll give that some kind of value, let's say 1,000 newtons here, and make sure it's going in the correct direction. Great, your study is set up. All we have to do now is hit the run, and there we have some results to take a look at. Now you can see it gives us a pretty nice indication of what's happening throughout the model itself. We have a legend that shows up over here on the right-hand side of my screen so that we can compare and contrast what the colors mean towards their stress values. And we can even take a deeper dive into each location and probe specific areas that we might want a little more information about to see what's happening right there. Again, a lot easier to see this now inside of our program than after we go ahead and manufacture the part. Now, that's all great for parts, but what about assemblies? How do we handle those? And it's pretty much the same thing. We have a very similar workout to go through here. We're going to take a look at this assembly of a set of pliers. And what I want to simulate here is us squeezing on the pliers on these two faces here of the handles. And we're going to assume there is something extremely hard stuck in the jaws so they're not going to move. And let's see what kind of stresses are created throughout the plier assembly themselves. So very similar again, we have ourselves a setup here of some materials. So I'm going to go ahead and apply a material to all of our parts. Again, our fixtures, going to create that stuck plate that's sitting here in between the jaws to assume it's not going to move anywhere. And then lastly, we're going to add our force to our handles themselves. One here and one here. And let's say about 225 newtons for our squeeze force here. Just like that, again, all we're going to do is run this setup here. And we have some results to take a look at. Let's dive into it a little bit here. Got to see some interesting things going on right about in the pivot area of the pliers right there. Just like I showed you in the last one, we can come in here and look at specific areas to see what's happening. And more importantly, we can go to the inside of the model itself. So I can simply come in here to our results folders, and we can take a look at individual items, faces, parts, anything that we want to take a look at and see what's happening at that exact location right there. So again, in a nutshell, pretty much parts and assemblies for static loads. If you have any questions or would like to see any more information about this, please don't hesitate to reach out to us. Thank you.